it's good to do the introduction. So if everybody who is going to be actively involved is unmuted and has your video on, then we can do introductions. So I can start. I'm Laura Clarke. I work as part of the team who is building the data coordination platform for the Human Cell Atlas. My actual significant area of interest is metadata, but I'm also partially involved with the Global Alliance for Genomics and Health efforts to have standards around data access for RNA-seq data. So I can immediately see Dave Rogers. So there you go. Dave, can you introduce yourself?
Hi there, yeah. My name is Dave Rogers, and I've been working on the HCA, the data portal, and the data browser. So I'm leading the team there.
So unfortunately, I don't have an easy way to sort of just go through names alphabetically. So if people can sort of volunteer themselves.
Chuck McCallum, web developer working on HubMap.
Cool.
Jason Hilton, Stanford University project lead for a new group called Lattice. We're the data coordination effort for the CZI seed network data.
I am
Heather Creasy. Oh, sorry.
Oh.
Go ahead.
All right, I'm Becky Steck. I'm from the University of Michigan, and I manage the software development efforts for the Kidney Precision Medicine Project's data kidney tissue atlas.
Hi, I'm Heather Creasy. I'm data manager for the Neuromolecular Omics Archive, or NEMO, part of the BICCN, and I promise I'm going to try to be as active as I can, but I do have 2 kids who are just starting online learning, and they're running around, and one of them just came in as I unmuted, so we'll see.
Well, you try your best, and we appreciate the challenges.
Yeah, I'll try.
Hey, I'm Tim Tickle at the Claremont Soul Observatory and the Data Sciences Platform at the Broad. I'm on the team for the HCA Data Coordination Platform, the Brain Cell Data Center, and LungMap2 Data Center.
Anybody else wants to introduce themselves, or are we going to move on to
this is Ambrose Carr. Hi, Laura. I'm a product manager at CZI. I'm working on single cell data visualization tools.
Right, so we're at the speak now, or you're assumed to be a passive observer. Cool. In which case, we should start talking about the actual challenges. Obviously, there are so many different initiatives in this space, and it's amazing. We've just seen everybody pulling together to find data to solve our current crisis, why this is a virtual rather than in-person meeting. And I think it's probably fair to say that data access and getting hold of data is always a challenge in these initiatives. So what are the problems that people face, either sharing data within their own consortium and the interfaces that they set up to do that, or cross-consortium data sharing, also problems? Anybody wanna start us off? So I suppose I will speak from personal experience. One thing that I've observed is, of course, just if having common interfaces, and that's the title of this group. If every time you want to get data from a new consortium, you have to write yet another set of API commands or interact with yet another UI and download data in yet another format, it just makes the whole thing take more time. So some standardization of interfaces means that it significantly lowers the barrier of interaction, because you don't have to start from scratch to get the data from a different source. Now, obviously, in the world of data sharing, we have not been as good as we could be at producing standards. The large resources tend to define what they do, and sometimes other people follow it, but we're also all very fond of thinking we can fit our own needs better. So, I mean, would anybody else like to speak about that, the challenges they faced trying to just get data from different resources?
I've seen some efforts trying to sort of aggregate data through some interfaces, and I think another problem that comes about is also like once you believe you have a common API, a lot of times the file formats or containers, they have schema that can be different, and so it ends up not being still interoperable data. I'm not sure if that's the point of this group, but just to put that out there.
So I think there is a data formats breakout, but it is clearly a challenge. You're right. The interoperable data, consistently accessible data that is interoperable is an issue. And if we come up with challenges, we can always ping them over to the data formats group and see if they line up with what they said, or whether we need to add anything to the things that they're considering solutions for in part 2.
I'm wondering if, for me, in my mind, I wonder a little bit about like, what are the large classes of APIs that are sort of needed? Like you're talking about data accessibility, right? And there may be other kinds of APIs for like findability, and maybe we have APIs that work really well at like secondary analysis, like getting sequencing data, these kinds of stuff, but maybe more difficult to have common APIs in like the visualization space, where there's more tertiary analyses and the world is a little more wild. I'm wondering if like there are particular API spaces that people see like points of pain in right now.
Anybody like to share challenges? I don't know if anybody in this room has been actively working as part of the COVID-19 sort of forces. What has there been? If you were to do this again in 5 years, and fingers crossed we don't have to, if we could solve problems that you faced this time round by then, what would you like to see? What would have made that easier?
So I guess, so you mean basically having all the data in one place in a unified format?
Well, not necessarily all the data in one place in a unified format. Obviously, from an EBI bias, all the data, centralizing the data and providing in a standard format, and providing essentially a single group being responsible for an interface is one way of doing it. But there are also the Global Alliance for Genomics and Health are driving forward having API specification standards, and that's something that I'm sure we will discuss in the next section. But not standard implementation, so it can be federated. And I think as data sets get larger and there is a diversity of requirements, consents, approaches and things, standard interfaces, but a diversity of implementations is a positive way to go. But yeah, I mean, I suppose sort of harking on
that makes sense. That makes perfect sense what you're saying. Yeah.
One thing that I've heard from that effort, or at least I believe from that effort, that is interesting to me is that so a lot of the analysis seems to have been focused on specific genes, and I had comments where like, can we just share this gene, and although we focus a lot, as can we share this file as an entity, and there's Beacon and all sorts of really cool things for findability for that. But the cell as an entity is not an entity we think about a lot computationally, mainly because it's hard. It's high resolution, lots of data. But if I had questions. Can we just share like an expression, like 50 expression matrices, but just 4 genes? And that I don't know of anything that does that, API or application.
Although that does raise one of the clear challenges around programmatic interfaces, not just can you get a specific file, but can you query to find which files have the information that you want, or which data sets have the information that you want, and then get back just that information rather than everything that was tagged that way, and sort of being able to do that filtering and subsetting of data. So I'm trying to reflect on things we've discussed. But clearly, just simple accessing of data is an important thing where standard interfaces help. Because if LungMap, HubMap, HCA, and HTAN all had the same programmatic REST interface, then anybody who was writing a third-party service on top of it could, who had the appropriate access rights, could get it all. Access rights is another thing that is a different breakout group. So important, but not our problem. But then that doesn't. If someone still then has to essentially get all of the data and then search through it for the particular piece they want, is that really a good solution? Is query? Do we think query is more important or less important than access, or a different challenge to access?
Well, this is really about access of an entity that is cell, not file, right? Because people may be willing to share, gene and not like the whole file of genes. So people might be willing to share like 4 genes of something that's not published, where they may not be willing to share all genes just because they're working on something and they're in process.
Yeah, I think that was the case. So I think that what you're saying, that subsetting, possibility, that made the willingness for sharing go up quite a lot, if that makes sense. So people were much more open to the idea of sharing a fraction of their precious unpublished data, as opposed to having to share the whole data set.
Yeah, I thought that was super clever. Another thing that it'd be interesting for this group to think about, and then we can jump right back to Sarah said, Laura, sorry, is that problem solving doesn't necessarily mean, I think, that we have to create a new REST API or a new interface. It could be that, there's some GA4GH standards that currently exist, and all the data platforms here don't adopt them on, so we're not interoperable, but we should be, so, smack our hands. That's problem solving too, is coming together and saying, let's get off our butts and do this. But let's go back to Sarah's idea here. Sorry, Laura.
Yeah, I mean, it does sound like, and I think this is a use case that, as far as I'm aware, hasn't been considered in the GA4GH space, because I will admit that in the problem solving, in the solution generation section, sort of part 2, I'm hoping that we will have people in the room who can talk in more detail about what GA4GH has done about these sort of data access APIs. But the idea that you could, like with Beacon, where you just put out allele frequencies and you don't, for your whole data set, you don't distribute any other information, would there be a comparable way? Now, of course, there is a tension here in an ideal world, everybody would be confident that they could share their unpublished data without being scooped. And if we don't want to make it too easy to make it easy to only ever share the bit of data someone needs and not ever share all of it, because there are things, if you don't share all of it, we can't discover the unknowns. And so I think we do have to think carefully about what the right approach is to not make it too easy for people to be overly precious about their data, and to incentivize rapid sharing, obviously in a way that makes sure everybody gets credit and everybody gets to do the scientific research and credit for the scientific research that they've done. But yeah, at the same time, I get that people potentially want to share. There are circumstances like this where sharing a subset of information allows us to move a lot more quickly.
I would almost want to at least.
Sorry, I think was there someone else trying to?
Go ahead, Ambrose.
I was just going to jump in and say I kind of want to push back on this idea that we don't have this capability right now, because all of our platforms are set up to serve single cell data, from raw data through count matrices. Maybe there's no simple way to serve the raw data, but anyone could cut out a piece of their count matrix and share it. And in fact, that's what they're doing right now. So, I mean, some kind of interfaces do exist.
Oh yeah, no, the interfaces definitely exist, but there aren't any standards across the interface. So as I said at the start, right now, if someone wanted to get data from HubMap and HCA and a different, stuff from the single cell expression atlas that isn't part of either of them, they would have to write 3 different sets of API calls and 3 different sets of, and deal with 3 different sets of output formats. So the barrier is quite high.
I totally agree with that. I'm just saying that problem of getting any count matrix is the issue. It's not that we can't get specific genes.
Well,
Okay.
I think Ambrose, is one important part of this need for this use case is that while the file is not shareable as an entity, smaller subsets like genes might be shareable. And so our current APIs are currently, I believe at least, unless you can point some out to me, which that's cool, are file entity oriented, right? And so you would have to be able to get the file and then subset, not have it subsetted behind the scenes and never access that file, which I think is the use case here.
Yep. Well, I guess I'd point at the matrix service as an example. It allows you to slice by cells, by genes.
You can you can get genes, just like one gene from it. I know you can filter, but I wasn't aware that you could just get one gene.
Well, the question is what's happening behind the scenes versus what's happening for the scientist who's querying, right? Like it doesn't matter if the application needs to go fetch 5 matrices or 10 matrices or 50 gigabytes of data, so long as the thing that the user gets at the end is the information they're looking for. But I mean, this is sort of an immaterial point, because I do agree with the root problem. It is very, very hard for me to go find the single cell data I want to find and use. I have to go to 10 places. They all have different interfaces. I have to learn something new for each one of them. It's extremely frustrating. When I finally do get the data, it's all in different formats and I still can't use it. So totally agree with the premise here. It would be helpful for me if we could define maybe one use case or one user that we're trying to serve, though, because I think it's maybe too large of a space for us to try to tackle universally all interfaces and all use cases. Are we thinking about visual portals? Are we thinking about the computational user? Can we get like just something tangible that we could try to talk concretely about?
Well, there's inspired by the excellent work that's already being done right now to investigate corona and COVID-19. They're getting all of the data for the ACE2 gene. I think that's a really good and you could insert your favorite gene in that query. That's clearly, and that has 2 users. And the prompting question did have both programmatic and UI sort of services. I think standardizing UIs is probably a less helpful thing to do, because different people have different preferences for UIs, and so there being a multitude isn't necessarily a problem. But if all services that wanted to build a UI could have a standard API that they knew they could get all of the data for a particular gene from all of the cell atlasing initiatives, then innovating in the UI space and allowing the competition to happen there would presumably be a lot easier, because there would be a much lower bar for a PhD or a postdoc with a fantastic idea of how to do it to actually try and get something up and running. But I suppose this is where I throw it back to you, Ambrose, and other people, is what are the analysis questions people want to answer, and that where a UI that would deliver all of the cell, all of the gene expression information for a particular cell type, or all of the gene expression information for a particular tissue system or associated with a particular phenotype would be helpful. What can you be more specific than get me all the cells that express this gene?
I would, unless you have something off the top of your head, I would challenge us to look at some of the concrete things we saw in the presentation earlier today. There were lots of really great analyses that people did when they were looking at co-expression of 2 different genes, for instance, where they were just simply looking at the expression of a gene throughout labels like tissues, right? Or other anatomical regions of interest. Those are 2 specific use cases that became extremely valuable, and we saw repeatedly throughout the presentation. But they seem like a very simple thing, but I bet you there was a lot of work to get there, and maybe it shouldn't have been so hard.
Yeah, I guess I can try to be concrete, Laura. I was pausing because there's like literally dozens of things you want to do with these matrices, and so enumerating the end use cases is complicated. As we've tried to aggregate them, fundamentally what it comes down to, if you're thinking about it from a data model perspective, is that you need to be able to do both arbitrary row and column selections and reductions.
I think one thing, can I kind of jump in just with a sort of real world comment? And I don't know whether there's a solution for this, but one of the challenges that we had was basically it was just knowing who had the unpublished data and approaching them, and then persuading them that this was a responsible thing to do in this public health emergency. Because, somebody has put something in the chat saying that cells by themselves won't make a nice data for analysis unless accompanied by metadata. And the key thing of that metadata was the cell type annotation for each cell. And by releasing the cell type annotation, the authors, the data generators of those data sets were effectively releasing kind of their intellectual scholarly work. And pre-publication, right? And that kind of filled them with trepidation, made them very nervous, essentially. But saying that, yes, you are releasing this data, and that was because it wasn't just the lung metadata. So if you go to covid19cellatlas.org, there's unpublished data from the cornea, the whites of the eye, from the heart, from another lung data set, and gallbladder intrahepatic duct, right? And it's the cell annotation that they're then putting out there, Anyway, the point is that was a lot easier to persuade people to do by doing it for a subset of genes only. If that makes sense. And I think the only way around that would be if there were some way of, this is kind of just thinking out loud now, but if there were some way of serving the data where you can only, let's say you can only access some arbitrary limit on the number of genes at a time. So let's say you want to look at 10 different viruses and they have 10 different receptors, that you would be able to access like each one at a time or something like that. So you'd be restricting. I mean, that may be some way of, persuading people to give access to their data, before the whole thing is kind of fully ready.
I think that's really interesting, Sarah. I mean, it sounds like the root problem is like whether we could convince people to reveal what they're working on so that you have an opportunity to go collaborate with them or to approach them prior to their publication or prior to them revealing it at a conference. Is that like a fair summary?
I think
that's one application. So basically fostering collaborations is one application. I mean, in this particular case, it was obviously the situation that we're in is obviously very, very special in this pandemic. And so, it was very clear that it would be those genes and that receptor. But hypothetically, if we had a pandemic, let's say with 5 viruses at the same time, and you'd want to have, 15 genes instead of 3 or whatever, then, there may still be kind of like a general case of allowing access for restricted subsets of genes.
This is interesting because a lot of times when we're thinking about interfaces, we're thinking about after the fact of publication, like file interfaces and stuff. Yeah. And there's things like sensitivity to access and how much information is shown, by still making it findable, right? That we can think through.
I think post-publication, that should not, I don't see why that should be an issue.
But that's the thing, we still don't have that solved. Right. I think we're adding another complication here with this COVID-19 solving a pandemic use case that I think we need to back up and remove that complication and look at all the published data that's already released and figure out how can we solve that. Then we can add in the next step of, okay, now let's work in the data that's a little more nascent. But I think that this
that's a fair point. That's a fair point. Yeah. Sorry. Yeah.
So maybe to sort of circle back, it seems like, because querying to get a subset of genes for to test a particular hypothesis is clearly a use case. Whether you want to then layer on top particular people hosting data restricting either which genes or how many genes someone can access is a sort of future thing to look at. But right now, still people, I think.
But I think
Ambrose,
Laura, that's absolutely right.
Yeah.
So there's no question about that. So basically querying small groups of genes is a use case, and that's, cell by gene kind of allows whatever X number of genes. So I mean and I think a lot of the portals do. That's thing. Then the second big use case that this COVID-19 kind of also highlights is groups of correlated genes. So here we're looking for ACE2 and TMPRSS2, the viral receptor plus the protease that cleaves it, and so on. So, that's we want to look for groups of cells that have those combinations of genes, and then once we've got those groups of cells, we want to look for other genes that are co-expressed with them. That was that immune module that came out. So I think those are absolutely like massive, use cases, as well as the old kind of thing that we always knew about querying which cells one gene is in. This is basically querying which cells a combination of genes are in, and then which genes are correlated with those genes in expression.
So we've got 15 minutes until we're going to be pulled in to hear from Francis Collins. So I realise that actually the majority of people who spoke right now are primarily from the Human Cell Atlas project, and so it would be great to hear from the other consortia who are on the call, and to whether you are facing the same challenges or whether you guys have different things that you're trying to address.
So this is Becky. I can start. Yeah. So again, Kidney Precision Medicine Project. So one of the reasons I was silent on most of the API conversations is that right now our main focus is on GUI type UI, user interfaces to serve different users more so than the. We do have a persona that is would be more interested in the APIs, but they're not the persona we're prioritizing right now. So we have a lot of problems that we're encountering. We're trying to break up there's the people that just want access to data. They want, we also have a remit that we need to make sure we're sharing our data, and before publication, in essence, as soon as it passes the quality muster standards that we've developed in our consortia, which is well before publication, we're supposed to be sharing all of those data sets. So right now our major goal is to be building platforms for just to make visible that we are sharing data and that it's out there. And we released kind of the very first beta version of that only a week ago. So we're still, in the infancy here and really trying to make sure that we're doing the right, nailing it there. But so then we're trying to separate that data, I'll call it raw data access, but it might not be raw data, but just straight up data access from data querying, right, and visualization. So the way we're kind of setting that up is two separate things under the same umbrella. So we have we're calling the repository where people access data, and then the explore area is where people can then do those different, some of the queries. So that sounds like that's where the conversation started to go from, is how do you query it in API to just, how do you query it anywhere, right? And so I don't know that I have much to add right now, is to say that we're in the same boat and we're really struggling with how to make those two systems integrated, because there's right now a real desire, a lot of our sponsors, for instance, are saying, well, so-and-so has a tool that does this and so-and-so has a tool that does that. Why can't you just bring that in? And trying to, explain the complication there of why you can't just adopt someone else's tool and slap it on top of the stack is where right now where some of the conversations we're deep
in. Anybody from other initiatives who wants to? Because that was really helpful. Thank you.
Yeah. Here you go. I was gonna say my name's Todd Valerius. I'm from a Good Map organization consortium, and one thing that we have been doing, as sort of to go on what Becky was saying, is that of course our software team has created an API, because everyone does, right? And I'm wondering, instead of saying that we all need to agree on something where we can access in a uniform way, at least perhaps some guidelines on what the API should do. Would that be enough? I'm not a software developer, so I don't know. But if the APIs weren't identical, but they adhere to some common sort of techniques or abilities, would that be enough to facilitate easy data transfer?
That's a really good point, and I think we might get to that more in part 2 when we're talking about solutions. But I think there's some learnings from the Global Alliance for Genomics and Health while common implementations aren't necessary, common specifications are really useful. But yeah, in the name of not going to solutions just yet, we'll leave that for part 2. But definitely hold that thought. Is there anybody else who wants to speak? Because I noticed I don't think we.
Or Nick, if you want to talk, I was going to say for HubMap that one interface challenge that we're trying to work out is just getting the data in the first place. Like, we're working with all these different modalities and all these different organ types, and they have different kinds of structures that make sense, and you can't, trying to support everything all at once doesn't work. So what sort of common structures can you have across these different things has been a challenge for us. Nick, you might have something else.
Yeah, Chuck, thanks. Chuck's obviously HubMap. I'm Nick Nystrom. I'm also with HubMap. And so I'd say we've been talking a lot about the API issues and what sort of queries we want to make available. We have a number of user stories. And I think the initial comments around what do we want to query as to single genes across tissue types, things like that. If we could identify those, they'll be valuable across HCA, GoodMap, HubMap, and some others from this meeting. That'd be really valuable to us. We have our first data release coming up in June, and so what we make available there for search and query, those are things we are building right now, and Chuck's at Harvard is heavily involved in that, and others. So those are outcomes I would like to see. We're addressing it. I agree with Todd that I think we've all built APIs. We're all expecting them all to somehow be the same now is probably not realistic, but we at least do a mapping of maybe a higher level to get at this. It'd be really valuable.
In essence, mapping use case to API strategy?
I think so. And also really having clear, let's say, documentation that's on par so someone can go and find what they need in each API very easily instead of having to navigate each consortium's own set of documentation to be able to build this. NIH has you're probably all aware, it has this Common Fund Data Ecosystem project going on. And maybe that's a place where some of this documentation could be indexed, made available, and maybe we could move toward these, at least for some use cases, move toward some APIs would be cross-consortium very easily.
Yeah, sounds that again one we should dig into more in the next session when we've got when we're meant to be talking about solutions. But there are definitely good ideas there that we could build on, and I think we are in a good place for sharing code and sharing solutions and having use case driven solutions, even if they are not identical across these different services.
Mm-hmm.
Yeah, so in addition to my involvement in the Neuromolecular Omics Archive, we're also part of the Common Fund Data Ecosystem at IGS under Owen White's group. And so, yeah, we're working a lot right now in sort of trying to come up with consistent APIs across Human Microbiome Project, NEMO, and other projects. And I think one of the areas where I struggle personally is making sure that we have the right user stories for our query interfaces and for other APIs. And so I think that talking about that with this group is really helpful.
So I'm Ben, with Code for a long time. I guess I have a couple minutes. On the API issue, I'm like, I don't know, there is a GA4GH RNA get working group. which I am, like ENCODE's been partially a member of for a little while. They do have something that's like a spec of an API for getting RNA data. It's probably focused on bulk data at this point, but I would encourage you guys to get involved in that. Everybody who's got RNA data matrix stuff they want to do, because they're on like version 2 of the API. There's a couple partial implementations. J4GH is a little weird. It's very like slow, a lot of writing documentation and a lot of like specking out APIs, but it is meant to be exactly what you guys are talking about here. I did want to say a couple words on sharing data, sharing unpublished data, and like maybe give you ENCODE's perspective on this. So ENCODE, I mean, going back to since before Mike Cherry and I were involved in this in 2012, always had a like rapid release policy, effectively, that once the data was QC'd and ready, it would just be released. And this has worked pretty well for people who've been around for a long time in the project, but as we got sort of new members in it, they have this persona, as you say, of not wanting to release their data before it's published, which actually really messes up the way the ENCODE Data Coordination Center works. As it turns out that if you, like our metadata situation is extremely complicated, as I'm sure Jason can tell you. We pay a lot of attention to QC, we pay a lot of attention to running pipelines, and if we wait till someone is ready for publication, like they're not gonna be up to snuff, right? So it just makes it worse. I think certainly HCA and other groups may have a much simpler kind of experiments that they work on. I think ENCODE has something like 80 different assays at this point. But one thing I think that I've been pushing a little bit is that when data is submitted to the consortium portal, it is released to everybody within the consortium, which in ENCODE's case is pretty large. HCA is also really large. There may be ways to leverage that sort of like group sharing initiative, that you can have access to unpublished data if you make an account, you log in, you sign an agreement. Like ENCODE has an agreement, we will not steal each other's stuff, right? And I think that that's really important. And I think that the issue with data sharing is a much deeper one than anything that can be discussed on any of the consortium or super consortium level calls. And that's that fundamentally the payoff system of science is broken in this regard, right? You want an academic position, you have to, especially one at a fancy university, you need to publish in like high profile journals. You can't waste 3 years getting scooped. That's really where the psychology comes in. So like, if you want a high level solution, like should consider talking to groups like Force 11 and thinking about ways where researchers can be fully credited for their data results as they are QA'd and finished, and not when they're even submitted to print application. That's sort of my spiel on this.
Thanks, Ben. I definitely hope we can discuss the GA4GH initiatives for standard APIs, because yeah, the RNA-seq API is definitely hitting some of these use cases, and as you say, I don't think anybody's tried to make it scale on the single cell data level, but it's definitely something. It's a good starting point, and one that I'm sure the community would, the GA4GH community would be super happy to see everybody here join and provide use cases and help drive the specification to the next level, so it does work for single cell data. I think, yeah, single cell data has a data diversity challenge that is I suppose comparable but different from ENCODE, in that we've got all of the different data modalities like imaging data and things like that as well. Although ultimately, in theory, you can boil it all down to these matrix files. But yeah, I think all of this is good. I want to quickly mention, I know Nikolai commented in chat about metadata, and I think it is a really good point that all of these API calls, not only is the raw data important or the process data is important, but having good metadata standards. I specifically avoided having a metadata discussion here because there is a clinical metadata breakout group happening now. There is a metadata schemas and ontologies working group happening, after this one, in this afternoon, this evening, there's I think every strand of this meeting has a metadata discussion in it. But definitely we need to make sure that any standards defined here capture those metadata standards as well as data format standards. So we've got like 2 minutes. I think moving into part 2, it seems like what are our shared use cases, particularly from a query perspective, may well be the things that we want to pin down more and establish or find out if there are good working groups, whether it's the GA4GH RNA-seq working group or other working groups that we can move this forward in, or with whether we need to establish something new. But yeah, if anybody wants to have the final word in the last 2 minutes before we get moved over back into plenary, then now is your opportunity. And I will just paste in, I will add to the document the link to the GA4GH RNA-seq GitHub repo, so people can, if they have time before we start on part 2, to have a quick squiz at their specification, you can see what's already been defined. And as I say, that's not about shared implementation, that's just about shared endpoints and lowering the bar to going to multiple systems.
I would like to say that there is something I think that's going to become very important in Atlas building, the entity of the annotation, and APIs and common interfaces around annotations, I think, are super helpful. There are some nascent efforts out there, but I'd love to be able to put power behind that, although it may be not for the next discussion. So
we are now to part 2 is 75 minutes. And this is where we're essentially discussing which are the most important problems. I think we really coalesced on one problem, which was how do people get hold of the data that they need? What are the query use cases? And so we may wish to spend a bit of time talking about use case before we talk about how to solve those use cases. But then this is definitely where solutions come. So if there's anybody who can talk, Ben, or about the GA4GH solution, or I think this is terrible where I can't remember who was talking about whether if we don't have the same interfaces, are there still ways to help lower the barriers to access, if that is a different option. I will admit I am a fan of a common interface, an actual shared API. Well, not standard specification for an API. But we can definitely talk about both possibilities.
Laura, I think there was also a bit of a discussion about lowering the barrier to submit data or to share data, and I'm wondering if we have time to discuss, current practice or solutions about enforcing the embargo, about tagging each piece of data, so you know where it came from, like hashing it so every vector is probably identifiably unique just with the data itself, or just ideas like that.
So there is a specific authentication and authorization working group in this breakout. I don't know if they've gone near embargo as opposed to consent-driven authentication, but that might be worth just quickly looking at. And because again, sort of not trying to. There are many things we can discuss here, trying to sort of keep on the sort of interface side of things. You're right, we haven't really talked about data submission and data contribution, and I guess maybe that's a missing piece, and one we should circle back to and figure out how to move on to, either if we have time in our 75 minutes, or if we have, if not, if there are people who want to get together to talk about it in another, in another meeting that we could schedule, for definite. Right, so it's nearly 10 to, so this is probably a good opportunity to actually get started. So we had a bunch of use cases that were sort of around query. And so it's what do we want to record those use cases, see if I can actually remember them. So there was the super simple find all the cells that that express this gene, and then there were ever more complicated that express these set of genes or other sort of co-expressed genes that you don't know the identity of compared to this gene. Are there other use cases? I don't know whether Becky, if you guys have been thinking about the more sort of UI driven stuff, what are the query use cases that you're targeting?
Right. So one thing to keep in mind with the Kidney Precision Medicine Project is we're bringing in a lot of other data besides just transcriptomics, single cell data. So we have proteomics and metabolomics data, a lot of pathology images and pathology metadata, for lack of a better term, and then a significant clinical, we're following, these are biopsies for research and have a litany of clinical data that we collect as well. So in addition, I'll just say feature instead of gene for a second. Sure. There's, I want to look at a particular feature. I want to correlate two different features that may or may not be from the same omics type. I want to correlate a particular cell type, right, with the different features. I want to in essence, any of the axes, right? I want to correlate the clinical data with a feature. I want to, or vice versa. I want to correlate. So oftentimes though, what we're focused on first is the single requests, right? Like a gene and correlate that with something else. But they just get, hairier from there.
Yeah, so I mean, I think Ambrose came up with a very nice, I suppose, sort of terse description, which is subset by rows or columns, and then information associated with the labels on those rows or columns. And that's how, you have a hypothesis, which subset of data helps you test those hypotheses, and how do you get that subset?
Just adding one clarification.
Sure.
That was most of it.
Okay.
As we get to scale,
yep,
most likely you'll need to be able to do row and column reductions as well, because downloading all of those data won't be practical. So if you had like 10 million cells, you may just want to know the average expression of a gene, and that would be more practical to do where the data lives than to download it and then do it.
So you've got the so there's the data, there's essentially the current level of data associated with your query, be that the whole matrix, the subset of the matrix, or even the subset of the raw data. But then there's the sort of summary level information. What is the average of a given feature across this subset? Is that
right? That's right. Or for a categorical use case, like say you were talking about cell types, you may not want to be able to count the number of each category in a metadata field, just because downloading that would be totally impractical. So it implies, I guess, a requirement for the data model and implementation.
Yeah, I suppose, that's almost where, again, you're sort of circling back to the sort of similar queries as are enabled by some of the genetic variation APIs, frequency information first, and then you can get the raw data, but that's a lot more effort. And so people want to be able to answer certain questions based on summary statistics before they, obviously for our data, there will hopefully be lower barriers from a permissions perspective. You won't have to wait 2 years to get much of this data, fingers crossed.
Yeah, definitely. Interesting to disentangle that too, to understand how much of that was driven by the permissions.
My sort of external view is, I think a reasonable amount of that was driven by the permissions, but at the same time, I think these days there are advantages, again, from a data size. Genomic data doesn't get as big as, say, imaging data, but it's still, I wrote down in the initial briefing a bunch of data. Are there modalities of data that we're collecting where it's going to have to be summary level information because we could just never support the download? Imaging seems like the obvious example, that this is going to be terabytes or even petabytes of data, so it's always going to have to be summarized. Are there other data types that we're facing where plausible download of a significant proportion of even the first level of processing, let alone the raw data, will be challenging.
I think that size is often a driver for that use case. Other thing is access restrictions. So consented and restricted managed and restricted access data often, but not always, can be accessed by summary, where it can't be accessed by the underlying data as easily.
Yeah, no, I mean, my understanding is right now, the general consensus is that gene expression levels can be released openly, even if the underlying sequencing data and alignment data can't be. But obviously, there may be circumstances where that would change.
That's where we drew the line for KPMP. BAMs and FASTQs are controlled access. The expression matrix is open.
So Maggie has just reminded us in chat, if the two scribes would like to hand over that responsibility to someone else, and there are other people willing to scribe, please feel free to share that responsibility. So just two people aren't doing it for the whole duration. Okay, so do we have a good summary of the summary of the use cases? Basically, subset features by rows and columns, and potentially reduce, sort of get an average of the value of those rows and columns. Is there another angle of this, another important challenge that we haven't discussed that we should get into before we move on to talking about solutions? Okay, I
guess I would say performance. Sorry.
Performance. Yeah.
You brought up a really interesting point. You and Tim were both discussing, are there data types that would be impractical to download? I think that's one side of it, but a more interesting question is, what does the user flow look like that is most useful? And I think a lot of that has to do with speed. And so it's not necessarily a question of practicality, it's rather, where do you do this compute to make it fastest? If somebody can get a summary of a compute or a question that would have normally required them to download data, spin up a notebook, and execute a complex analysis either on their computer or on a server, instead in a few seconds, if we choose to do that on a browser, then that is a much more powerful application that we've provided to a consumer. And data model questions will make that or break that. So it's contemplating whether we want things to be interactive speed or not, whether we think that's practical, I think is a useful consideration, maybe as like a stretch goal.
No, that's very reasonable. That's almost the sort of difference between the point at which you transition from mostly providing things programmatically to mostly providing things in a UI, because if it's not interactive speed, it's still good to have UIs, and sort of people can, just like, old school running BLAST or FASTA, you sent the request and then you waited for an email, because those things just weren't interactive. Right. There are probably always going to be things that you want in a UI that work in a similar way. But these days, most people want a UI to be truly interactive, as opposed to queue something up and wait for it to finish.
Yeah, I think that's right. And I would add that, here's maybe an opportunity where we can generalize. I know I was pushing back on it earlier, but I think that most use cases that serve browsers or serve command lines probably can be framed as a general solution and executed from either source. The speed that they execute may make the user experience better in a browser or in the command line, but probably we can frame an API that would be used in both cases.
It certainly makes life easier for the people who are building the portals, because I think, and please correct me if I'm misinterpreting here, there is still a consensus across the community that multiple UIs that meet slightly different user communities and different needs are a good thing. But if they can all be built on the same underlying API queries, then it's much easier to spin a new one up because you've had an idea about how to better serve this community versus, you know, the one who's primarily focused on metabolomics data rather than primarily focused on sequencing data.
Yeah, I think that it's important. I would like to throw out that, and correct me if I'm wrong here, Ambrose, that it's less important to talk about user experience, and it's more important to talk about the things what entities are important to us and the things we need to do to those entities. And those things will support a variety of user experience. And then the performance can be both behind the implementation of the interface. So some of that is magic there. And some of it is, of course, making sure that specific entities and actions on entities are available to us, like summarizing entities, for instance, groups of entities. That's sort of a context for me that sort of at least rings true.
I think so. I guess the way I'm thinking about it is, what are the requirements? That's what I'd like to get out of it. If we have an agreement on the requirements, defining an API becomes a little simpler. Is that a fair articulation of what you were saying, Tim?
Yeah, I was pushing the requirements towards a certain space, which is like, what are the entities? Like defining the requirements as entities and actions on entities, and less about user experience, even though, you know, some of these use cases have very strong user experience requirements too for scaling.
Right. Okay.
But,
I guess I was advocating for one level up.
Great.
Not so much what are the data model entities, but, you know, which is what do people want to do?
Yeah, sure. That'll start it. Yep.
So we've got a very general level of what people want to do, which is, you know, subset rows and columns and potentially get summary statistics across the values in those rows and columns. But we may want to bring ourselves back to real world examples, actual queries that people want to make, to help us ground what we're proposing.
I'd like to just to jump off that, Laura, and ask the imaging community if there's any here. Like, this is very RNA-seq thought space, I think. So other modalities, do those genericizing, like require generic pieces, do they fit your data modality?
I think it's important to distinguish, as someone else already did, instead of saying gene, to say feature. That will apply to things like chromatin accessibility regions and stuff like that.
Yeah, and I mean, it's kind of, but imaging is different. You don't necessarily have an entity that you're making queries on. You just got rasters and there are multiple layers.
So
so then, go ahead.
I was just waiting to see if there were more people from the imaging community. I've thought about this quite a lot. I have not come up with a good generalization of the observations times features matrix that Jason points out directly to images. Now, the imaging experiments, most of them can be summarized, and there is an intent to summarize them as some kind of aggregation over an area or feature type. The common one is cells, of course. We're counting either the intensity of a protein across the cell or the number of RNA molecules, or in some high resolution cases, the number of protein molecules. Those do eventually make their way into the same matrices. And so it could be that we can fulfill a subset of the use cases for those spatial imaging technologies in the summarized form. And then there would be another set of APIs and use cases specific to the images. That to me feels less overfit. I'd be interested to hear people working on images if they think that's reasonable or if they push back on that.
Anybody care to comment?
I mean, I think my sense is that, yes, we would like to be able to get that sort of per cell stuff in the image, but just like how the best way of segmenting and identifying what the cells are can be very much an open question. So I think sometimes just, yeah.
So 2 use cases for sure. I completely agree with you that cell segmentation and summarization is very fit to the individual images. It's extremely challenging and it requires expert curation in almost every case. So there's a great need and utility to have the raw images and be able to navigate over them and convince yourselves that you trust the summarized view. Is that fair? Yeah. I personally have less experience in the imaging space, and so I feel less confident in suggesting what the right APIs would look like. There's also much greater complexity. I know somewhere here we have Jason Swedlow, but it looks like he made his way into a different group. He obviously would be well suited to comment at length about this. But I'll just stop and say that I think it's hard, and I wouldn't stuff it into the same use case that we were contemplating.
So listening to this conversation about RNA-seq and imaging, something that we haven't necessarily, I mean, I think there's an implied need in the queries that we're talking about that we haven't been explicit about, is that these queries need to ultimately be able to happen across multiple data modalities. I think Becky kind of alluded to that in the work that they're doing as part of the kidney precision medicine initiative, not just RNA-seq data or just imaging data or just proteomics data, but obviously ultimately you want to find out, you want to be able to run this querying and pull up all of those modalities. Do you think it's fruitful to discuss now that, or do you think we're better off trying to develop a standard for, say, the most common data type right now, which is single cell data type right now, which is really the sort of sequencing modality with RNA-seq and ATAC-seq? That's also arguably one of the simplest. Not that single cell RNA-seq is simple, but you know, or whether do we actually want to broach the how would you make this work across multiple data modalities now? Okay, the lack of response makes me think that maybe if we stick to worrying about these are all thoughts about multiple data modalities, I think, yeah, but concentrate on thinking about something that works for sequencing, and then as more and more data becomes available, we will have to reconsider if the solution we've chosen for sequencing data will work for these other modalities and for the integration use case. But I think, yeah, there's a lot of more unknowns in those spaces. So
just to say, I think it does work, but it implies something, which is that you've accepted that the transformation from the images into some kind of summarized form of features by observations worked. And as it was pointed out, that's often questionable, but ultimately the goal is to get to some kind of summarization of cells or other features. But it can be super interesting to like get distance from a blood vessel, for example, for each cell. So it's broad, but the goal's there.
But doesn't that mean that the entities for image, at least the transcriptomics imaging and the RNA-seq imaging, overlap in one space, and then there's additional entities that might be available in imaging because you have more raw image? Will we sort of throw that away for sequencing? Like it doesn't. To me, it feels like there's different levels of processing that may have certain entities that you would expose with the interface, right? Some features are cells. Some other features in imaging might be tissues, for instance, or other things that there's more experts on this group than I would say, than I can say. But it just feels like we're really not saying that they don't disagree. It's just that there are more features that one can create. In fact, actually, you can make custom features at that level of analysis for imaging, right? That you wouldn't be able to do for RNA-seq, even though you could do custom things later on in tertiary analysis, like pseudogenes and things like that for both. So you see it, but it's just, does that make sense, or am I rambling? Probably both.
Both. Yes, that is the framing I was hoping for, that you appropriately generalize to observations, which could be a cell, it could be a pool of cells, it could be a bulk sequencing assay. It doesn't really matter. and features, which could be genes or proteins or blood vessels or anything else you want to measure. Then the onus is on the data curator to understand whether it fits into that model or not. And my thesis here is that most summarized data views can fit a observations by features matrix, and that's useful downstream because a lot of our statistical tools require a structure like that. Now, if that was wrong, the scientists on the call should jump in right now.
The only caveat I would have, since no scientist jumped in, is observations by features for sure, with annotations, so like metadata for each column and row. But we can stay away from metadata for this one.
We shouldn't ignore metadata, but I think we should be careful about not, if we're going to talk about solutions and potential specifications for solutions or even existing implementations, that we shouldn't try here to solve the metadata standardization problem, because there are other working groups trying to solve that.
Also worth noting, Tim, that I guess like kind of implicit in this is that you would have those metadata. In RNA-seq, we've sort of formalized that anything not an observation of gene expression or an abundance of a promoter region, of reads in a promoter region, are metadata. But I think that comes from the fact that we're looking at a model that we're trying to look at with multivariate statistics. And so we see a bunch of features that all look the same to us, and we say, okay, so we'll model those with some multivariate model, and then anything else is a covariate to that model. And so our systems naturally fall into that source, but there are other statistical models that would simply take the observation metadata and model those as additional features, and then they would just structure the features differently so that you would add different weights, or you would allow the model to learn the weights. So definitely those should all be interpreted. But just to say that so long as they fit that same sort of blockwise form, there's some flexibility downstream to use those the way that they're needed. So both good points, Tim and Laura.
So because I think before we dive into any details about anything, it would be good. Nikolai again made a very good point in the chat, which is about whatever APIs we establish, whether they're standardized or not, there needs to be a way of discovering what features are available in a particular API. Does anybody have any thoughts about what the right way to approach that is? Because obviously anybody with RNA-seq data will likely have genes and cells, but people with different, imaging data, if we can get that that great sort of distance from a blood vessel, or distance from an invariant feature from whatever the common coordinate framework ends up being or something, is another feature that some people will serve and some people don't. And yeah, so what are people's thoughts about knowing for a particular instance of this query service what you can query?
I have a sort of tangential question. What's our policy in this meeting about like calling out observers? I see people in chat whose opinions I think we would very much benefit from.
Yes, and that's fair. That's a very fair point. I think it would be great if people who would like to ask questions and pose ideas. I also don't want to force anybody to do it. But that said, if what you do is post comments in chat, your comments might not always be noticed or acted on. So I think that's the fairest thing to say.
Yeah, and the chat itself, like unless it's someone's job to copy that out, it's going to be lost at the end of the session. So
yes.
Yes.
Some people may have poor audio connections.
Oh yeah, and that's, although as someone I think pointed out in the plenary session, if your computer audio connection is challenging, phone is a good solution. And I think Zoom provides toll-free numbers for many locations. assuming you're in a position where you have a phone as well as your computer, which not everybody will be. But
yeah, you can dial in the Zoom numbers just using the meeting ID.
But something Nikolai touches on here about, well, I want to query for a specific gene, but what do I query for? We all know that one gene can be called numerous things, and so this is where we're going to touch on ontologies, that it's important to use ontologies because that will inherently bring in synonyms and a structure where you query for fibroblasts or T cells, and you also get the different types of T cells. But that's not going to work for every type of entity or every field.
Yeah, I mean, that's where the advantages of a single source of truth and a centralized data repository that does consistently do that, as opposed to many different data repositories who have the same set of interfaces but may not adhere. And yeah, common metadata standards absolutely essential to support consistent querying. I mean, gene names is a really good example because yes, if you've got the ensemble gene IDs, you've got the HGNC, the Hugo gene names, and then there are other clinical communities don't always name their genes the same as HGNC has decided to name them, and all of those sorts of things. Definitely going to be a challenge here, and something that we have to think about. And so although that's, I think, slightly different from the knowing what features you can query. So you can query genes, but what language can you use to query those genes? That's almost two different axes of documentation.
So that's what exactly you just said. The word I was thinking of, documentation. Is this something we first need to document as a community? What are the use cases? And then we document vignettes or examples of each of these use cases so you can see exactly what format everything is in or what standard language we're looking at to identify the genes and stuff like that.
I think the question of ontology is very important, but something that I also think is important, at least for this quick conversation that we're having, is a sort of a separation between interface and ontology. So sort of, if we know the entity, we know we'll need certain things, we can adopt a ontology, right? So like pointing out, oh, we need the gene, whatever the ID is for the gene, that should be an ontology. And then moving on and just at some point selecting one and let someone manage that ontology in another way will help us focus on sort of like what the common interface would be. Unless you want to push back on that, Jason.
No. I think you framed it well.
If I could add one area where I think an ontology is important up front, though, is when you talk about anatomy. So that's one way to link different modalities in together. So while I agree that you could, I think gene symbol, gene name, that type of thing is somewhat solved. It's still complex, but I remember doing microarrays 20 years ago, and it was a nightmare. So I think that's you could deal with that now. An area where we've struggled, and I think Becky can chime in on this too, is around anatomy. There's many ontologies out there, and I think that might be an area that raises the need to understand that particular area as ontology, not to say we'll get to that later or we know we need that, but actually bring that forward so that you can combine things more readily up front.
I would like to echo this. So in HubMap, we are dealing with ontologies that have been developed across many different efforts, funded by different sources. And oftentimes these ontologies were developed for very specific purposes, either for a disease or for developmental, etc. What we need for HubMap is one vision to create an ontology for 10 plus organs across 25 different assays. So there really needs to be a different view of the development of these ontologies. And it would be great to discuss this more. In fact, we are planning to discuss this also in the CCF session this afternoon.
Well, yeah, I was going to say, I think it's really, this is clearly very important, but I don't think it's a problem to be solved in the common interface session. There is, in the metadata schemas and ontology breakout, one of them is about anatomy and the common coordinate framework in metadata. I am certain there will be other sessions that also talk about this, because it's a fundamental challenge to cell atlasing that you know where in the body a sample came from and where those cells belong. But yeah, I think probably not our problem to solve.
Going back to your idea of sort of use cases that Jason was just talking about, that I think that's one area where I know in KPMP, for example, they've thought clearly about this and refined that constantly, because you make a very good point, is that if you're a data architecture scientist coming in to grab a bunch of things, it's a very different use case than searching for ACE2. And you have to build, it is interface versus API, I guess, but the documentation of both of those is really important to be able to reveal that. So going back to what I brought up too early in the morning part, this idea, because I don't understand, are there ways to agree on common elements of an API that makes it easier to adopt on top of the different stacks, as Becky was saying? Or is that something that there needs to be more standardized in an agreed upon common API that people all share and contribute to?
So this is a great opportunity to introduce the way the Global Alliance for Genomics and Health defines their standards. And I was looking to see if Ben was still with us, and it's not clear if he is. So I will give you a slightly less expert view, but very happy if other people want to jump in and add detail, and I can definitely connect everybody here to the group, because that may be a great place to actually move this discussion, is that working group. But I will screen share, because I think that will make this easier. And I want to find Chrome. There we go.
And Laura did not set me up to ask that question for her presentation.
No, it was just super well timed. Thank you very much. So we have, now this is where I have to find it in all the tabs I have open, where I put it. Right. So hopefully you can all see the open API documentation for the RNA-GET API. And this is a specification for the endpoints that should be implemented by someone who wants to expose the RNA-GET API. And so basically all of the APIs that GA4GH define work this way. There is also HGS-GET, which is more about raw sequencing data. There's a REF-GET, which is about reference genomes, and they all follow these sort of standard principles. And there is a working group that maintains the standard, but there is a governance process for extending the standard. They recently hit version 1.0, and then, but if we came to them with use cases that they don't cover, Ben's just shown up. I may well put questions to you.
You're doing a great job, Laura.
They're very happy to hear extra use cases and consider extending the API or changing the API if it doesn't meet the needs, because this is clearly a community where such a standard would be valuable. But it's important to note, this isn't about your implementation. You can implement underneath the endpoints, you can implement it in any way you want. It's just that you have the standard endpoints, and that means that everybody can know if they're approaching someone with an instance of the API and they have a Python notebook or they have a script, it should work in the same way. Obviously, it will not always be the case, but I think what they've got right now, they've started with the relatively straightforward stuff, which is finding projects and sort of filtering things based on specifics. So if we look at the expression example, there is a schema which is what might be returned by a query about expression information. But so this is, I will stick the link in the minutes, but this I think is a great idea, and it would be good to understand, would this work for the community? Is this something that people could adopt? If it isn't, why isn't it? And could we evolve it so it would? And if we can't evolve it so it would, what's the right solution that has a similar sort of similar ethos? I don't know if anybody, whether Ben, if you've already implemented this for ENCODE, if you want to talk about your
We have not actually implemented it. It has, unfortunately, we're been down a developer for 2 years. So it's currently on my plate to work on the development of it, which I don't get to very often. There actually aren't, I don't think there's a fully functioning implementation at all. There are a couple implementations that are partial. There's a couple GitHub code bases that you can use. Like I was using specifically, looking at adapting the Candig has a sort of reasonable Python Flask API implementation of it. Although it's missing a lot of parts to it. So essentially what the API is like, as you said, it's like a metadata description of expression data. Because of it's designed to capture across, an infinite number of projects. It's not very well controlled. They don't worry about. No one right now is worrying about ontologies too much, which is going to get them in trouble. I think that the two parts of the data specification are, one is sort of a expression matrix specification, which I believe uses a Loom, which is an HDF5 format. And then there's I don't know, I would just call it like a signal track, like very skeleton API. I don't think anyone has actually implemented the sort of signal expression value API, except I heard that HCA had one that is quasi compliant to this, but like I remember when I was trying to get into this, I'm like, oh, I should just fork HCA's code and use that. It didn't appear to be particularly useful in that regard. So it is actually the group moves pretty slowly. They're actually really, they just released 1.0, but then nobody implemented it effectively because they're already on sort of a 2.0 type discussion thing. Now is a good time to sort of like get involved and think about what they're saying. Like the details and the structure of the API, I think, are less important than what actually the content is going to be. And especially, probably somebody in there needs to be worried about, how it translates, because it's pretty much a bulk RNA API at this point. Like how it translates to single cell and how to relate those is probably a segment that someone needs to get in there as soon as possible. It's not really my area of expertise either. So, but the concept is, I think, like even if the literal API spec itself isn't useful, the concept is valuable. It's sort of, that's why I was in the other meeting. I was discussing like IHAC and sharing data that way. Just having a situation where everybody who has, everybody who's a data provider, like can go in and at least sort of sign off and agree to say like, okay, I don't care what API it is. I will implement whatever you specify. It's all in, it's modern, uses, Swagger IO. There's a script or a website that will like test your API and like see how compliant it is. It's pretty useful. It's mostly just a case of developer time. And then on my end, I actually got stuck because I actually don't have any data in Loom format or anything. So I actually would have to write code that takes our RNA quantifications and turn them into something that could be distributed before I could even write a test case. I was fooled by someone had a code that claimed to do this for RSEM, but it was just a stub. It didn't actually do anything. So I have to get that code from someone else.
Maybe this is a conversation for a later time, but it's sort of confusing that it sounds like the RNA-Git interface is thinking about, I don't know, file entities maybe, because as opposed to a file schema, I think it's more important to specify sort of like the interfaces to get things in the schemas for those files as opposed to like, it has to be Loom as opposed to H5N or whatever it might be. but because then it feels like the interface isn't actually talking about entities like cells and genes as much as it's relying on that container to do those things. But maybe this is sidetracking us a little bit.
No, I think that I may have just stated it in an unclear fashion. In fact, I'm not 100% sure that it demands a Loom interface. It's just that that's one of the ways that you can implement the descriptors of what comes out of it in some sense. It's not meant to be like, it doesn't deliver like URLs to files specifically, or actually, wait, maybe it does download. I mean, the weird part about the choice of an HDF5 format is that it doesn't lend itself to random access. So, I mean, I wish I had a little more, I wish I had a couple dozen more hours to work on it and sort of figure out what actually it's supposed to do. I'm mostly just following it to make sure that I can catch up to it one day.
Well, maybe for the purposes of this conversation, though, you gave a great overview, and so this is something nascent in the community that if the group here wanted to leverage and extend and build towards their own specific use cases and real implementations, it sounds like it might be an opportunity.
Yeah, and especially the way I view these things is that we're all going to implement something on our own end anyway, right? It's just a matter of prioritization. And like at ENCODE, I've been meaning to have some sort of like, I wouldn't really call it an RNA get API, but like some way of like bulk distributing quantifications for probably 5 years now. It's just never made it to the point where I had the engineering resources to devote to it. But if you are implementing such a thing in your consortium or in your web portals, like it makes a huge amount of sense to go both directions with like sort of a GA4GH core super consortium like this, right? Because you can come in and say, well, this is what we did and this is why. And then you can look at what their spec is and say like, oh, this is why they're doing it this way. Or if you're building an API, you're like, well, I'm not really sure what to name my URLs anyway. Like, well, what does GA4GH does? At least you're like partway there. I mean, it's, you know, it's baby steps, I guess that's what I'm trying to say, right? So it's important to know what other people are trying to do, even if you have to, you know, sit through some pretty boring meetings on API specifications.
So I guess as we're sort of 35 minutes from, or 30 minutes from the end of this session, if from what people have heard about GA4GH and the API specifications, you know, bearing in mind large organizations, momentum of change is not low. Just the effort involved to generate momentum of change is not low. Do people think that first a common API specification in this style is a good way to provide a common interface? Because that's the most important question, actually. What do people feel about having a common API specification? Not a common implementation. Obviously, people can share implementations if they want to, but we all have slightly different ways of storing our data and ways of storing our metadata, so that, you know, common implementation is not necessarily so convenient. But if we had a shared specification, is that a good thing?
When I think about these things, I always think about a shared specification, although that can be implemented however you want to. But there were some voices in this group here about how that may not be the only kind of solution. So I would really like to be able to understand that, because I don't sort of think in that space. So I don't really understand how we would do it otherwise. But I think it's cool if we could. So I'd love to hear about it.
Okay. Sorry, this is Bruce Herf. I'm on the HubMap project. I'd like to throw out sort of a bit of an alternative. So we're doing the common coordinate framework and defining our data in terms of RDF and XML, as in using a semantic web technology. And as I've been working through this, and I don't think I can, you know, give you a simple pat answer as far as like what all the interfaces would look like. But essentially, with following semantic web, linked open data technologies, essentially, you don't really have to worry so much about the API because you're publishing your data in terms of these ontologies, in terms of vocabularies that can evolve, and you can use reasoners to sort of like bridge the gaps between different vocabularies, as in, you know, one vocabulary uses terms in a certain way, but if you have the right linkages, you can actually say, okay, this term from this ontology is this term from this other ontology. So in a way, what you can do is you can publish your data using standard sort of RDF technology, and you use Sparkle, which is more or less just, it's like SQL. It's a little more limited and a little more clunky, but basically you can change how you're thinking in terms of, rather than, you know, what does my API look like to get this kind of data, to get that kind of data. You can build this huge API that no one implements or implements poorly. Or you can say, you publish your data using one or more ontologies that, you know, people are starting to agree upon, and then we can use semantic web technology to link vocabularies where needed, or using the same vocabularies. And then as far as querying is concerned, as far as for getting out specific data or aggregating data, you can use Sparkle, or even just grabbing the RDF triples directly and doing sort of on the fly analysis and using whatever tools you want to use with it. So it's sort of, it's a little bit different approach. That's basically what the approach that we're taking. But I just thought I'd throw it out there. It's like I said, it's not a full pat answer. I can say, oh, everybody just do this and it'll work out. But it's another way to approach this.
So the way I'm grokking that is that you're talking, I'm hearing one is focusing on interoperability and like being able to map between ontologies as opposed to using a common interface. Is that the correct way of characterizing that?
Yeah, that's part of it. Yeah.
Yeah. I was just thinking about it, like, is there a possible downside to sort of having this shared API that everyone is aiming for? A possible cost if people aren't actually implementing it that well is that you can spend more time getting tripped up by the gaps in this implementation versus this implementation if like everyone is sort of implementing different subsets and they're not all implementing them to the same level. That could be more confusing than if everyone just different things.
So GA4GH has tried to address this by having compliance and having compliance testing, and that if someone is going to declare that they're meeting the standard, they have to be compliant with the standard. And anything that is not obligatory as part of the standard is clearly documented as such. And so you will be, someone who is using a standard API will be aware that these things are less likely to be there. That said, I think even for compliance, things that are optional, they have to implement, but they have to have a sort of return function that tells someone that it's not implemented. It can't just be not there. So GA4GH have thought about this and have tried to address that with this sort of compliance requirements and compliance testing. And I think that's essential because you're right. If you define a specification but don't test how well people meet the specification, then it doesn't actually necessarily save the people implementing against it any time. So that is a really, really important issue.
It feels to me like there's a bag of work that has to happen, right? So if there's a common interface, the burden of work is implementing that common interface, even if you don't use those use cases, or stubbing it out so people know you don't have that entity. On the other side of things, if you don't have a common interface, but you're focusing on interoperability, then it sounds like the bag of work is having a mapability between ontologies. And that could be that, and that is was an end-to-end kind of thing. For every ontology, you have to be able to have a mapping for it. So it sounds like there's work in both spaces. I'm not sure which one's bigger, but and thinking of like cost trade-offs. I like that framing. What are the cost trade-offs?
The tricky part about the semantic web stuff is that it pushes like all the work onto the software consumer. I mean, this stuff's been around for years. I mean, our API, I guess, is in JSON LD. It can be converted to RDF triples. You can put it in a Sparkle store if you want, but it's like nobody really, like it's not how anybody thinks about it. And in the end, like there's a huge amount of like front end software that has to be written and used widely to sort of make that a reality. And in the end, right now, like you're probably better off just implementing something that delivers data to people. That's
right. Right. To Bruce's point, though, I guess a generalization of that is making a difference between like a REST API sort of set of queries and a query language set of queries. So you could use Sparkle, you could use SQL, you could say, oh, we're going to put all this stuff in BigQuery and we're going to document what the tables are, and you can, have at it and use SQL as your data query format, and people could build interfaces or build their own indexes against that. Another one is, and another example is GraphQL, right? This is saying, hey, we don't want to make all these REST APIs. Let's come up with a query language. Now, GraphQL doesn't use all of the extra fun stuff of the semantic web to specify what the ontologies are, but it's a similar approach. So it's GraphQL, SQL, and the Sparkle, languages. And I think, the advantages of the Sparkle type stuff is that it pushes a lot of the work onto the metadata, as the metadata is part of the API. And it's very important that that's done well and it's done, that people adopt it. So yeah, so that's just my main point is differentiate between the REST version and the query version of the APIs.
David, that's a great point about the metadata. Like that's like, yeah, that will work. Like if everyone had sufficiently logical ontology driven metadata with, in any sort of format that's transferable, then that could work. But I think most of the situations that we run into, like the other call I was talking about iHack, is that people's projects are sort of half done in a lot of cases. Like they're not going to go back and rewrite or recollect metadata. Like you end up with that when you're sort of federating across a bunch of different people, different systems, you're always going to end up with sort of the minimum, set of comparable fields, and that you need a mapping for that somehow. And the advantage, I mean, you probably need both, right? I mean, I think that's sort of the other way of putting it too, because you're going to have different users. Some people are just going to want to curl expression values, and some people, are going to want to do logic and reasoners, right? So, like both of them are they're not independent projects, but they serve different use cases.
So that's one of my big concerns. On one hand, this semantic web stuff offers a lot of possibility, but at the same time, if it raises the bar so high that a PhD or postdoc or staff scientist who knows how to deal with Loom files or H5AD files and how to query by gene and order name, then can't do anything with the data, we've changed the barrier rather than lowered it. And I think that is a very important issue, that the majority of people who need to use this data, some of whom want to use it programmatically, are not, amazing technologists who have all of the understanding of Sparkle and semantic web and all of those things. They just want to say, I want lung data for ACE2 in this format, give it to me.
Yeah, but I'm not sure that the user persona for these common interfaces has to be the computational biologist. I feel more, for me, like this is the developer who's making these consortia and these data centers, because you can have a layer of abstraction like a CLI that touches these interfaces that allows someone to programmatically interface with things in a more comfortable way depending upon what they're used to. And you can have many of those kinds of things. So you can definitely have a presentation layer on top of what these interfaces are. But I don't, if the group feels differently, that's fine. But I'd rather focus on the user persona as the developer of a data center for these kinds of things.
I would also like to add that we might need to implement user interfaces that allow bench lab scientists to capture this data in meaningful ways. So for instance, in HubMap, we have this registration user interface, and it generates JSON data, but it's doing it in a very easy to use way. 5 minutes of training and 1 minute per registration of a tissue piece. So I think we need to then also provide interfaces that capture data in more meaningful ways, in ontologically and spatially explicit ways.
Oh yeah, I mean, for data capture, clearly we're going to need very clear interfaces to deal with this thing. But I am also aware that there are people who will want APIs rather than UIs to be able to do large-scale integrative analysis, and they don't want to have to learn Sparkle to do that. And so we do need to always think about our users, and it may be that a semantic solution is the right solution for integration with consortia, the data coordination centers of consortia. I'm slightly skeptical, but very happy to be proved wrong. But I think the sort of API that GA4GH standards are going for is an API that could be used by anybody who's happy to use an API, not someone, and that's, I guess, the difference between REST and maybe more complex query solutions. Being able to do relatively straightforward queries with a REST API so anybody can use them, versus being able to do really complex sort of co-expression or co-occurrence analyses require with really tightly defined semantics. It requires a much higher level of skill.
Yeah, so for me, I'm wondering here, and maybe I don't want to call you out, Dave, but you know, since you're walking away from your computer right now, I would love, if for me it feels like there's got to be another way to define a common interface. It doesn't have to say REST or GraphQL or things like that. Like, is there not a way to have a common interface where these REST API and GraphQL and all these things are just implementations to get it done? Like, or am I wrong that those move actually towards a little bit of the implementation space?
Yeah, I think a lot of it depends on, as we keep coming back to, is defining what it is that people want to do. If there's something that people want to do and they want to do it over and over, and there's a certain set of variations that we need to accommodate, then you end up with some sort of don't want to use it anyway, domain-specific language or a very specific way query language that addresses a very specific sort of niche. The Sparkle stuff, that's like, well, this is the same set of tools that work for everything, and SQL is the same set of skills work for kind of everything. So but there's a learning curve to get those. So again, it's back to the use cases. What is it exactly that people want to do, and build maybe some tools that do as specialized languages to do that, like these CLI tools that you're talking about, or dumbing down the whole thing and putting the user interface on it, where you have the very simple and an or filters on the faceted search kind of stuff.
And I think you have like multiple layers. You might like, and related to the REST thing. JSON data can be represented as JSON LD and be brought into Sparkle as well. So you can imagine having certain levels where, everybody's talking in terms of RDF, and you can have the advanced Sparkle interface, but you can also publish your data as JSON. And if it works, if it's published as JSON LD, then you can still have that simple REST interface, but it can also be brought into a larger reasoner that you can use with the RDF triples and stuff like that.
Yeah, no, I agree with that. You should consider doing that with your APIs. Although I don't know if GA4GH is LD compliant or not. Probably not.
I think that's been mooted as a possible route for future development, but I think, again, nobody's doing it in anger right now. Just because I think we've got 15 minutes left, it would be good it would probably be good to at least attempt to, I think there's been some chat about this, put some information in the blue box about the problems that we think we're solving, that we want to solve collaboratively, and then how we move forward sort of after this meeting. I think the consensus seems to be that we're wanting to provide, to sort of lower the barrier to answer queries of sort of querying for features, and providing both, was it observations by feature matrices, and querying to generate those observation by feature matrices. I think was a nice sort of terse description by Ambrose. And then and also potentially providing summary statistics of those observation by feature matrices where the matrix itself is just too big to move, because that will inevitably be a problem. You know, if at any point we actually have millions, if not trillions of cells, then moving this data around, even if it's just numbers, will become quite cumbersome. Does that seem like a reasonable summary of the problem that we've spent the last hour discussing? Or would anybody like to propose sort of alterations?
I think that's good. But one thing I would add is that I've just been happy listening to everyone's discussion of the types of APIs and problems that they've been trying to solve. And I'd be really interested to keep that discussion going, and to learn about the types of problems that everyone sees, I guess, the users or scientists of their initiative trying to solve, and see if we can learn across. That feels to me like the most valuable thing that I could take away from this. So the next thing is recommendations of what we want to do, and is therefore, you know, I think Ambrose, your suggestion is a really good one, is to continue on a working group, people here and other people, about what are the problems, the query use cases and the data access use cases that people want to solve are. So then, while we might not start with a sort of solution proposal, we can better share understanding and get to a solution proposal. Yeah, I'd love to hear like maybe a 20-minute presentation from each of the groups that are here. What are the key challenges? What solution are they proposing? Maybe that could seed a discussion about how we could all work together, or whether there's opportunities for dividing and conquering. Yeah. And then obviously we brought up the GA4GH spec. So if people want to be connected to that that initiative and the specification that they're defining to help make sure it works for single cell data as well as bulk data, we can totally do that. I'm very happy to. You can email me, Laura at EBI, or you can also Google. There's a link in the minutes to get engaged. Are there other standard initiatives? I know the EBI works in the RDF space and the semantic web space as well, and I always hear about hackathons and other things. Is there a international collaboration around standardization for those things that is also worth seeing if people here want to engage with? I mean, there may be things that I can find out about through the EBI, but I don't know anything off the top of my head, because again, that's one of those places where I've been observing rather than interacting. Okay, so sounds like from the lack of response that there's nothing that immediately springs off anybody's tongues for a sort of GA4GH like organization who's doing RDF and stuff. So I will inquire at the EBI to see if there is an ongoing initiative that it would be good to get people connected to. But if there isn't, then we should definitely take it forward. So
who is going to volunteer to herd everybody into the, you know, three or 4 months worth of presentations about what the challenges people are facing are, and to get to a better consensus about whether the GA4GH RNA GET initiative or another solution would be a good way to lower the barriers for everybody to have common query interfaces. I mean, I can do one round of cat herding, but this is not my domain. I work on data contribution and metadata standards rather than consumer interfaces. So I suspect I am not the best person for this job.
Tim, would such conversations be a good fit or a bad fit for the portals calls that we have stood up?
We've had those in the portals calls in the past, and so certainly fine to continue that conversation there for sure. I very much welcome it. Yeah, so yeah, sure.
So Tim, do you want to give a little advert for the portals call? Because I don't know how many people here already know about its existence and would like to get more involved.
Sure, yeah, definitely. So this is a call that started from the HCA, but does not necessarily have to be about the HCA. In fact, it's better if it isn't. It happens, now it's happening once a month, but we used to have a cadence of once every 2 weeks where a group of portals get together and we talk about what we're doing, what we're up to. We've talked about use cases before in the past, actually, and sort of shared use cases. We have shared use cases in the group, and it's okay. We understand we all do similar things sometimes and do unique things other times. But we all get together and we talk about what we're doing. And in our current context, we talk about how to interface with the HCA DCP. When new APIs come online, they're presented to the group. They're given feedback and things like that. But there is no reason that we couldn't have like interfaces from HubMap and interfaces from Brain there too and such like that. So that would be really cool to see how but it's really focused on the programmatic person, right? The programmer trying to interface with these data centers and with each other.
That sounds like a great place to carry on these conversations. Does anybody else have an alternative proposal? Because I think not inventing new meetings is good for everybody, even though in theory we now have slightly more flexibility because, you know, we're all stuck at home. Not inventing new meetings is better for our souls.
And I'm happy to have agendas, so.
Okay, so it sounds like the proposal is to carry on this conversation in the context of the ongoing HCA portals call, bearing in mind it's called, I suppose, a HCA portal, but it is generally about portals for cell atlases rather than specifically the human cell atlas work. And then the next call is, presumably your next few calls are already scheduled, Tim?
If people want to just put their emails in the doc here of who want to be connected, I'll directly connect you and add you to the calendar invite. And also, for a while, I've been having it. I have the idea of having sort of a group of people making the program for it. So if we want to have like HubMap representation and Brain and other kinds of groups, sort of planning the program, we can change the name of this to something else. It's more powerful with all of us together, and I'd be happy to change the name in the context of it.
Cool. So yeah, so write your names either here, or you should be able to find Tim's email address hopefully somewhere in the Keystorm system if you want to reach out to Tim
adding it to the blue box.
Yeah. And then it seems like our first step is to actually make sure we have a shared understanding of our problem space and where our problems are shared and where they're different, and then we can decide what the best place is to is a shared specification for an API the right solution, and what style of API is it? Is it, you know, standard REST, or is it one of the more semantically driven services, or both? Anybody else like to add any other final thoughts?
Just a thank you to you guys for putting this on, and Laura for leading us through this one.
Looks like you guys made some good progress. All right, does everybody understand what happens next?
Do we essentially hang up now? Because
yes, you leave this meeting. You'll leave this meeting, and you won't be able to come back to this Zoom room ever again. But there are other Zoom rooms for the next meetings. But like I said in the chat, the Google Doc will remain available to you. After you have a lunch break or whatever break it is in your time zone, return to the plenary, right? So that's the Zoom link on the welcome page. Got it?
Lovely to speak to everybody, and thank everybody for their input, and I'm sure we will bump into each other again in other breakout rooms.